In this video, we will see how to import time series data for viewing in version 3 of Drishti. This is using the raycasting method. Um, Previously, you would have probably imported time series data using import time series. Now, this is for the slice-based version, but because in the raycasting version in Drishti-3, we can view very large data sets. What I have done is, instead of splitting or saving each time step in a different file, for the raycasting version, and this is only for the raycasting version, collect all the time steps into a single large file. So for example, if you have say 512 cubed time step, each volume is say 512 cubed, and if we have say 10 volumes or 100 volumes, then what I do is collate all that into a single volume of size say 512 by 512, and then all the time steps. So it would be 512 by 512 by 5120 or 5000 or 51200 if you say 10 or 100 time steps. So basically I just go on attaching each time step along the z-axis and create a very long cylindrical very long volume essentially. So let's import one such data. This is an example here. This is bone compression data, and there are say 11 time steps. So what I'm going to do is I'm going to select all these time steps. Now this is the data that I had formerly converted for slice based rendering. So I know that each of these is a raw file, and each contains a single time step. It's not a very big data set. Each volume here is just 256 cubed. So I'm going to drag and drop that in here. So these are the time steps, which I'm going to treat it as a single volume. I can treat that as a raw files. Okay, cancel. Raw slab files, sorry, it's not a single raw file, raw slab files, and we don't have any other header information. So, and I don't want to create histogram. I'm just saving the time because I know it's a byte data. So these are the different time steps. As you can see, we are going through multiple time steps here. So the total volume is 256 by 256 by 3072. It's not particularly big data set, but for our demonstration that will serve the purpose. So let's go and then save the data. This importer in Drishti-3 pre-release alpha will allow you to save data in 3 different formats. The .bvf is the format that Drishti-3 Drishti-3 raycasting version is going to use. The pvl.nc format is what the slice-based version can understand, and then there is also metadata format, meta image format, the .mhd format that Voluminous, the cloud-based renderer that Drew Whitehouse has written, which is available from the NCI ANU website. So for importing Voluminous expects .mhd file. So this importer will allow you to export the data into these 3 different formats. So you can choose your format from this drop down box. So what we'll do here is we'll use say 4D volume, for example, and then we'll go ahead and save. Now what it's doing is it's going to save the data into 2 files. The 4D vol.bvf, it is going to that's the header, or it contains the metadata of for your volume, and then the actual volume will be saved in .hdf5 or hdf5 format, that is in .h5 file. Your data is going to be blocked up into 32 cubed say pieces, blocks, and further I create an octree. So what I do is I go in and subsample the data the volume, and then save these different subsampling levels, which I call as level of details. So you'll have full resolution volume, then the half resolution volume, quarter resolution volume, and so on. So I create about 5 different levels. So it's done here, and let me show you how this thing looks. So this is the file that I created. The .beaver file looks almost exactly like the .beaver.nc file, and the h5 file. So let me show you that h5 file. This is using the HDF view. So these are different level of details. So I'm saying these different level of details. So this is where your data actually resides, and I'm also saving the minimum and maximum values for each block within that data. So your data is blocked up into, say, 32 cubed blocks, and then for each block I'm saving the min and max value. The idea is to use those min and max values to select the appropriate blocks for rendering. Now the way rendering happens in the recasting method is that the appropriate blocks, the blocks that contribute to the final rendering, are selected for uploading into the texture memory, and then they are rendered. So even if your data is big, which cannot be accommodated in the texture memory, still we can render that data, because we are loading only a partial data or partial volume at a time for rendering, and this can go into multiple steps. So I might do, say, 100 200 iterations before you get the entire image on screen. Probably depends upon how big your data is. So now we have saved this bone compression data, and then we'll go in and see that data in the next video.